Yeah, on the last lesson we talked about using trig functions, and we used an angle to find out what the ratio of sides should be so that we could find a missing side length. Here we're going to talk about inverse trig functions, and they do the opposite thing. They help us find out what angle measure would give us the ratio of for tangent, cosine, or sine. So just like we did last time, we can find inverse functions in our calculator, and if you notice in yellow above sine, cosine, and tangent are the sine inverse, cosine inverse, and tangent inverse. And this little -1 thing here doesn't tell us to multiply by -1 or anything like that. It's actually an exponent that tells us we're looking for the inverse function. So that to the -1 power, all that indicates to us is that this 1 is the ratio of side lengths for sine. So 1 represents what the fraction opposite over hypotenuse means, and we're trying to figure out what angle fits that function. So in order to calculate sine inverse, cosine inverse, or tangent inverse, we just press the second key, the yellow key, and then we hit whichever function button we want to use, and we type in our ratio value, so in this case 1, and we can figure out what angle, if we took the sine of that angle, would it give us an answer of 1. And that angle is 90 degrees. So you can check, if you take the sine of 90 degrees, you should get an answer of 1. Similarly, we can do that with cosine. If I take the cosine of some angle and it equals 1, then that means the angle was 0. So the cosine inverse of 1 gives us 0. That means that the cosine of 0 degrees is equal to 1. And tangent, if we take the tangent, sorry about that, if we take the tangent inverse of 1, we get 45 degrees. So if we take that means if we take the tangent of 45, so let me actually show that here. The tangent of 45, if you went and plugged that into your calculator, you would get 1. So the tangent inverse of 1 is 45. So it kind of, if you know 1, you can find the other type thing. Let's go ahead and try that. We're looking to find out what angle, if you take the sine, gives you 0, what angle, if you take the cosine, gives you 0, and what angle, if you take the tangent, gives you 0. If you don't have a calculator handy, then go ahead and just make sure you jot these down, and you can do them pretty quickly when you get to class. So if you could do these, you would get that the sine inverse of 0 is 0. So that means that if I take the sine of 0 degrees, it's going to give me a opposite over hypotenuse, that is 0. Cosine inverse of 0 gives me 90. That means if I took the cosine of 90, it would give me, you guessed it, 0. And the tangent inverse of 0 is 0, same as sine. So that means if I took the tangent of 0 degrees, it would give me 0. Okay, so just so you know, when I ask for the sine inverse, that's the answer I'm looking for. Cosine inverse was 90, tangent inverse was 0. Those are all representing angle measures. These should look pretty similar to the last lesson, except in this case, I know two side lengths, and I'm looking for theta. Remember, that's theta. That's our Greek letter that we use in trigonometry to represent angles. We're trying to find out the value of this angle theta. So we can start by labeling our sides. 5 is my opposite side. 14 is my hypotenuse. And this side that we don't have anything written down for is my adjacent. So I know that my opposite side is 5, my hypotenuse is 14. That should trigger me to use the sine function because opposite and hypotenuse gives me sine. So we can write the sine of this angle theta is equal to 5 over 14. Now we want to get rid of sine so that we have theta by itself. We can do that by taking the sine inverse of both sides of this equation. And that's going to look like this. Now the sine inverse and the sine function are inverse functions, which means they cancel each other out. So if I take the sine inverse of sine, those two things are going to cancel each other out. And I'm going to be left just with theta. So on the left, I just have theta left. Sine inverse and sine canceled each other out. Over here, I need to use my calculator now. I hit the second function, press sine, that gives me sine inverse. And I type in 5 divided by 14. And that tells me that that angle I was looking for is approximately 20.9 degrees. So this angle over here, theta, is 20.9 degrees. And of course, if we wanted to, we could go ahead and find this other angle. Since we know this one's 90, this is 20.9. This one should be 69.1. Let's do the same thing for this guy. My opposite side is over here. I don't have anything labeled. 8 is my hypotenuse, and 5 is my adjacent. So I know something about the adjacent side, the hypotenuse. That should hopefully indicate to you we're going to use the cosine function to find this angle. So the cosine of theta is equal to 5 over 8. To get rid of the cosine and leave us just with this theta variable, we take the cosine inverse of both sides, like so. And as I always say, you should show all your work, you should show these steps. Cosine inverse and cosine cancel each other. Now we just need to go into our calculator. Second cosine, 5 divided by 8, tells us that that angle is approximately 51.3 degrees. Right there. So go ahead and try and find the missing angle theta here. Again, label your sides and use the appropriate sides and the appropriate function. If you don't have a calculator that has the sine inverse function on it, then just get down to where theta is equal to some function inverse of a fraction. Get as far as you can and check your work when you get to class. You can always do the calculation really quick at the beginning of class.